Alright, let's look at the homework 11.9, problem number 8. Alright, so what we want to do is we want to approximate this definite integral using power series. Alright, so let's do that. Alright, first we're going to try to rewrite this guy as, alright, just to rewriting a little bit, so you have a 1 over a double negative 1 minus negative x to the 6, right? So we can write it as the summation n goes from 0 to infinity, and then you have a negative x to the 6 to the nth power. Right? So we can rewrite this guy as, let's make it prettier here. And it starts from 0 to infinity. Then you have a negative 1 to the n. Then you have an x to the 6n. Alright? So we can replace this guy by its corresponding power series. So it's going to be integral from 0 to 0.3. Right? So it's a summation. N goes from 0 to infinity. Then you have a negative 1 to the n. Then you have an x to the 6n with respect to x. Right? So if you find the antiderivative, which is summation, n goes from 0 to infinity, and negative 1 to the n is just a number, leave it there. Antiderivative x to the 6n would be x to the 6n plus 1 divided by 6n plus 1. Then you're going from 0 to 0.3. Alright? So if you plug in x equals 0.3, you're going to get the summation. N goes from 0 to infinity. Right? So you have a negative 1 to the n. And then you have a 0.3 raised to the 6n plus 1 power over 6n plus 1. Right? Minus, if you plug in 0, it's a minus 0. So I'm not going to write that down. Alright, so what we're going to do is we're going to try to approximate it correct to 6 decimal places. Alright, since this is a alternating series and the error is bounded by bn plus 1. So remember that the error, right? So which is the difference between s is the actual sum and the partial sum, say n, is bounded by bn plus 1. Alright, so let's compute the sum bn so that we know how many terms we need to add so that we can ensure the correct to 6 decimal places. Alright, so open up a GeoGebra. Alright, open up a GeoGebra and I'm going to define b of n. So this is basically bn. So bn is going to be, alright, so we have 0.3 raised to the 6n plus 1 and divide by 6n plus 1. Right? Hit enter. Alright, so we have a function there. Alright, then what we want to do is we want to make sure that this is small enough. So I'm going to compute, for example, b1 is equal to b of 1. And the value is going to be, let's see, hit enter. I need to change the option here, rounding to say 10 decimal places here. All right, so you have a value there. All right, so you have a 0, 0, 0, 0. So in order to be correct to 6 decimal places, error needs to be a little bit smaller. So let's try b2. All right, so it's going to be b of 2. All right, which came out to be that. You can see that it's a 0, 0, 0, 0, 0, 0. So this is small enough. So bn plus 1 is b2. So n is equal to 1. All right. So I'm going to sum up all the way to 1. So it's going to be just 2 terms. All right. So we're going to say numeric. All right. So that's just turned into a decimal number. All right, so expression is going to be, so this is going to be a sum. All right, so summation right? So it's going to be negative 1 to the n multiplied by b of n. Then variable is n, and starting from 0 and ending at 1, right? Significant figures, so it's going to be 6, right? Then hit enter, right? So we got 0.299969. So 0.299969, right? So that's going to be the approximation correct to, correct to 6 decimal places. Right, so let's type it in. Right, so it's 0.299969. Right, so let's check the answer. All right, looks like we got this value correctly. All right, that's it. I hope that this was clear.